My name is Mariano Zeron, and in this video I'm going to show you how to slice high-dimensional MoCaX objects to obtain MoCaX objects with a lower dimension. So let's take a look at this code that I've got here. So what I want to do is build a MoCaX object for a two-dimensional Black-Scholes pricing function. So as we've already seen in another video where we cover how to build and evaluate high-dimensional functions, we build our MoCaX objects by running this part of the code. This builds the first part. This is the first part of the building process. Then we finish building the MoCaX object that corresponds to this two-dimensional object, as you can see here from the description of the object. We have a two-dimensional object. This is the domain. The first variable corresponds to the spot, the second one to the volatility. This is how I've chosen it. And now the exercise is the following. Let's say that you've got this two-dimensional object, and what you want to obtain is a one-dimensional object. Possible reasons may be the following. Whenever you want to add two different MoCaX objects, you're not going to be able to add them if they have different dimensionality. But let's say that you're only interested in adding the MoCaX objects at a particular dimensionality. And you know that the MoCaX object with big dimensionality can be sliced down so that then you can add the objects. So the library provides that possibility. And the way that you do it is by calling a method of the MoCaX object called slice. And to this slice functional method, you need to pass this set of pairs or tuples. Now, each of the tuples specifies a dimension and a point at that dimension where you want to cut the object. So basically what you're doing is, if you think of the domain of the MoCaX object as the domain of a function, let's say, consider a hyperplane where you want to cut the domain. And you define that hyperplane by this collection of tuples. In our case, it's going to be, out of the two dimensions, I want to take the second, which corresponds to the dimension indexed by 1. Remember that pretty much all indexing in Python starts from 0. So index 0 would correspond to the first variable, which in our case runs between 50 and 150 and is the spot. And the second variable corresponds to index 1. And we want to cut it, let's say, at 0.3. Of course, you have to bear in mind that you need to cut it at a point that makes sense. Given that our domain, the second variable, runs between 0.1 and 0.4, it has to be a value in between those two values. So we take 0.3 and we slice by passing that tuple or that set of tuples to slice. We do that, print out the object that we obtain as a result, and we see that we get a sliced object which has now one dimension instead of two. So compare, for example, what we had at the beginning, which is the original MoCaX object that has dimensionality equals to 2, and the second one that has now dimensionality equal to 1. Now, for example, if you wanted to evaluate that object down here, and let's say that we want to evaluate it at the point 100, that should be the same as evaluating the first object, the one that has two dimensions, at the point 100 and then 0.3 for the second variable, because it's exactly at 0.3 that we sliced that object. And if we run these two lines, we'll see that the result down here gives the same result. There's a disparity here at the end, but that's basically computer noise. Essentially, the values are the same. Just as easy as that, you can alter the dimensionality of the object, and in particular by going down. And you can go down not only by one dimension as we did it here, you can go down from many dimensions to just a few, with pretty much all the flexibility that you want. So in this video, we've covered how to slice objects. In the subsequent video, we're going to show you how to do the opposite, that is starting from a low dimensional object and how we can extend it to a high dimensional object. See you then.